All right, hello class. There we go. I think we're recording now. Hello class. Today we're going to work on some writing ionic equations. We started this last week, but we want to work on some more. So I'm going to share my screen and so let's get right into it. So once again, writing complete and net ionic equations. Once we're done, the sub's going to give you a practice sheet. And actually, we're going to work on some of that practice sheet, so hopefully the sub already gave you the paper. Notes, we took notes on page 10 on how to do this. And in most classes, we did example A and example B on page 10 in our yellow packet. One period, I believe first period, we only did example A. All right, so we're not going to do page 14 of the white packet right now. Instead, I'm giving you another page which is helpful in help building that. So we're going to skip page 13, the card sort. We're going to skip page 14 for now, and instead, we're going to work on the new page, the new handout. All right, so we're going to work on questions 1, 3, and 5 of part 1 and question 1 of part 2. We'll do those together. So here we go, new handout. We're going to do the odd ones. And it says, as the following ionic compounds dissolve in water, you want to show how they split apart. We call it dissociate. So how, when they dissolve, when they split apart, what do the ions split into? So right now we got a crystal lattice, we have sodium hydroxide, everything's together. But when we add water and our solid starts to dissolve, it starts to turn aqueous. What we're going to see is that the sodium ions, which have a positive 1 charge, are going to dissolve. And the hydroxide ions, which are negative 1, are going to dissolve. All right, so these ions, look at the chemical formula here, it's just one of each. So when they split, when sodium hydroxide splits, it splits into 1 sodium ion and 1 hydroxide ion. I'm going to change to my skinny font so that way I can try to fit more in the screen, especially in the next problem. Here we go. So next one, we got aluminum. Aluminum sulfate. So when it splits, what does it split into? Well, think about what you needed to make this. You needed 1 aluminum, which has a +3 charge. You needed a second aluminum, which has a +3 charge. And then you needed 3 sulfates. And each sulfate's a -2, right? So we got to figure out how many of each ion. The charges have to add up to 0. So we have 5 ions here making this up. So I'm going to erase this. And so how do we show that? So if we have aluminum sulfate and we dissolve it in water, then we will get 2 aluminum ions, each one being a +3. And then we're going to get 3 of the sulfate ions. Each one is a -2 charge. So that's what we would get. So 2 of this and 3 of that. Adds up to 5 ions, which there's 5 ions there. Let's look at number 5. Number 5, we got a coefficient. We got a coefficient of 6 in front. So for right now, let's pretend that 6 isn't there. Let me just use some white eraser or white pen to cover that up. And so look at what we got going on here. We got ammonium sulfate. We're mixing with water. So when we mix it with water, we're going to get all the ions to separate. So NH4 has a positive 1 charge. And look, we got a 2 here. So we got 2 of it. All right, so we got 2 of that ion. That's going to dissolve in the water. And then we just have 1 sulfate, just 1 sulfate. So that's how you would handle it if there wasn't a number, a coefficient in front. But there is a coefficient in front. There's a 6. So it's saying we got 6 of everything. So what we're going to do is multiply. So if one of these would have 2, and now we got 6 of them. 6 times 2 is 12. So we would put a 12. Oh, what happened there? 12. We got 12 ammonium ions. And instead of having just 1 times 6 is 6. We would have 6 sulfates. So 12 ammoniums and 6 sulfates would split apart and dissolve in the water. All right, so you can try to do 2, 4, and 6. I'm going to post an answer key to this so you can check your work. Let's look at what you do for part 2. For part 2, I already have the complete chemical equation written for us. So what you need to do is, first thing is to look at your pink sheet and figure out which one of these products is going to be a precipitate. And KCl is going to be aqueous. We can look that up on the pink sheet. And if you look up magnesium hydroxide, you would see S. So it's a solid, so that's a precipitate. So we put a down arrow there. And then we want to balance the chemical equation. All right, so we got one KCl, one Cl here, two Cls here. So I'm going to start by putting a 2 here. And then if I have 2 Ks over here, I would need to have 2 Ks over here. And then that gives me 2 hydroxides, 2 hydroxides. I got 1 magnesium, 1 magnesium. So everything's balanced. You can write the number 1 in. You don't have to. So 2, 1, 2, 1. So I'm going to split everything apart and show how many of each ion are present. So anything that's aqueous, I'm going to split apart. So I have, and I'm not sure why it keeps connecting lines for it. It's driving me crazy. All right, so I would have 2 Ks. And potassium has a +1 charge. And then there's a hydroxide here, but there's a 2 in front, so I'd have 2 hydroxide ions. They're aqueous. And then over here in this substance, I would have 1 magnesium ion. And magnesium is +2. And then I have chlorine. All right, remember each chlorine, when chloride is an ion, has a -1 charge. So it'll be Cl -1, and because I have a 2, I have 2 of it, so I'm going to put a 2 in front. So those are the ions that I'm starting with. These are all the ions that are dissolved in water. Over here, I end up with 2 KCl's. This is a double replacement reaction, so K links up with the Cl. It's still aqueous, so that means those ions are still separate. They're still dissolved in water. And then I would have 2 Cl's. And these are all ionic compounds. They're all ions. They all have charges. But look, I got a precipitate. So what's different here is that the precipitate, I keep it together. So the precipitate stays together. And now I'm going to cross out the spectator ions. The spectators are the ions that do not change. So they're the ones that's hanging out, spectating the reaction, not participating. So I got 2 Ks on both sides, and then I have 2 Cls, 2 chloride ions on both sides. So this is what changed. And when I write this out, I'm going to write what's left over, what I then cross out, and that's going to be giving my net ionic equation. I always like to reorder it, so I always write the positive one first. So I'm going to write Mg2 positive. It started out aqueous, reacts with 2 hydroxide ions, which start out aqueous. In solution, they come together and they form a precipitate. And so my precipitate is MgOH2. That's it, I'm done. It's a lot of work. Your hand will hurt a little bit, a lot of writing. But that is how we write complete ionic equations, and that's how we write net ionic equations. So I would like you to finish up this. When you're all done, take photos of the front, take photos of the back, put those photos into a Word document, crop them, rotate them. I don't want to be looking at 90 degrees, breaking my neck, and have to go to chiropractor because you didn't rotate your image correctly. All right, so rotate the images so text appears this way and not this way. And also crop out what's not necessary so that way your text is as big as you can get. All right, so I hope you all have a great day, and I'll see you soon.